So I'm William Peavy, and I'm going to be doing the second lab for Chemistry 1211K, which is to, the objective is to prove the law of conservation of matter. A quick disclaimer, I was planning to do this today. I had planned to do this probably last week. Well, at least this weekend. I was planning to do it today. And last night, while I was in bed, my throat started bothering me. I wake up this morning and I have a sore throat. Now, today's Thursday, so if I don't do this today, tomorrow's the due date. And tomorrow, I guarantee you, my throat's going to sound even worse. It doesn't sound too bad today, but it's going to sound really bad tomorrow. I'm positive, so I got to do this today. For this lab, to prove the law of conservation of matter, we're going to take copper 2 chloride, which is a blue-green crystal powder. It's more like crystals than powder. And we're going to dilute, we're going to mix it with water. We're going to let it dissolve in water. And we're going to add a little piece of aluminum. And what will happen in the reaction is the copper in the copper chloride will be released and the chloride will bond with the aluminum. Now the point of this is we would weigh the aluminum and the copper chloride water mixture before the reaction, and then we weigh the products after the reaction, and we compare them to see if the masses are very similar. If they're very similar, that proves the law of conservation of matter, because it states that matter is not destroyed or created, but rather it just changes forms. So right now, I have a disposable spoon. I'm gonna get a gram of copper chloride, which is actually kind of hard to get in here. I'll clean it up. It's okay. I'll clean it up. I got it. So we're getting about a gram, which I almost have. Just a little more. Once we get a gram of this, we're going to add 10 milliliters of, distilled water to dissolve the copper chloride. And look at that, I got a gram. Yippee. And then once we mix them together to dissolve them, I have a gallon of distilled water. I pour it in this cup to make it easier to get it in the graduated cylinder. At first we're gonna put in 10 milliliters of water, distilled water. And then after we mix that, we're going to add the aluminum foil and let the reaction take place while I swirl it around for a little bit. I'm going to mix this. And once I add the aluminum foil, I have to swirl it around for about 5 minutes. I have an analog, I have a wristwatch because I'm recording this with my phone. It's kind of hard to mix. Once it mixes though, it becomes like a blue liquid. Alright, almost done. Alright. So, put that there. We have a little watch glass that we're going to put over it once we put in the foil to let the reaction take place. I'll sterilize this after I'm done. Okay. Oh, I clean everything once I'm done, so I don't have to worry about that. Now, before recording this, I already went through and did my measurements for the lab notebook and all that. And in my measurements, I think I effectively proved that the law is correct, because for my percent recovery, which is a comparison, you take the mass measured from the reactants and the mass of the products, and you find the percentage of that ratio, divide the reactants mass by the product mass. And for mine, I got like 99.7%, so I think that's pretty close, if I do say so myself. This does, if you do it right, of course, I think I did it right. It does effectively prove the law of conservation of matter, and it proves that in chemical reactions, mass is not lost and it's not gained, it's just changing. So like in this reaction, I had a slight, just that tiny little deviation of 99.7%. The glass here is going to fog with the reaction, so probably that tiny bit of mass is lost in like gas release. But the mass is still very close, and that's the point of the law. That's what the law states. Matter is not lost or created, it is simply going to change its state or change its form. In this case, the copper chloride contains copper and chlorine, and once we introduce aluminum to it, what's going to happen is the copper and chlorine will break apart, and the chlorine attaches itself to the aluminum, leaving the copper by itself. So that piece of aluminum we drop in while we swirl this around is going to turn into, or well, what we're going to be left with is little pieces of copper in the mixture. The copper is of course going to be solid, and the liquid is going to be aluminum chloride. Got another minute left to swirl this around. I'll show you my result from this, just to show that I did it correctly. I might be swirling it a little too fast. I don't think it matters whether you swirl it slowly or quickly. The point is just to get them together and mixed and all that. And that this effectively proves the law if done correctly. And that's the point of this, is to show that it is in fact true, and I think it does that. We should be almost done. a little more, and then it'll be done. All right. Oh, I'll show you here. This hand. See this murky liquid with the little pieces of copper at the bottom. All that dark, solid stuff is the copper.